Hello everyone, so welcome back to another week of Intro to iOS Development. This week we're going to be going over networking, and this is the first part of a two-part series that we're going to be doing on the topic of networking. And so because this is the first part of a two-part series, the next week's lecture will be much more demo focused, whereas this week we're going to focus more on the concepts and going over like our slides. So as always, let's just start off with a review. So our first question for the day is, what is one reason that you would use a collection view over a table view? And the answer to this question is C. You can scroll in both directions, and you can use a grid layout. So as you guys might remember, table views show data in a list, and therefore you can only scroll vertically. But collection views give you a lot more freedom in the layout, and you can scroll in both directions. So our second question is, how do you set the spacing of a collection view? So this is a trick question. The answer is C, you cannot. You need to set the spacing of the layout. So as you guys might recall, in order to set the spacing, you have to actually set the minimum line spacing and minimum inter-item spacing properties of your flow layout object. And then you actually use that layout object to create your collection view. And that's how you affect the layout of your collection view. So let's just start off with maybe an overview of what we're going to cover today. So today we're going to be talking about a number of topics. So one, we're going to start with networking, and then we're going to talk about HTTP requests, and then we're going to talk about external libraries and CocoaPods, and then we're going to end the lecture with a talk about closures. So the first thing that we're going to talk about is networking. So what does networking actually mean? So networking is basically a term to describe how computers talk to each other and share data. So in our case, we are trying to connect our app to the greater internet. And the purpose is so that our app can then talk to and also exchange information with other computers on the network. So why do we want to connect our apps to the internet? This might be an obvious, answer to you guys, but let's just look at some of the apps that you guys probably use every single day, right? How do these apps get the information that they need to basically render their screens, right? Like, how does Facebook get their Facebook posts? How does Gmail get their emails? And how does Google get their news stories? Well, let's just look at an example of maybe the Gmail app and think about how we would implement this screen with what we know so far. So you probably can look at the screen and know immediately that we want a table view, right? And up until now, the way that you guys have created table views is that you guys would create an email model, right? You would then create an array of email objects, and then you would actually create the table view or a collection view, and then you use the array as the data source. And so the emails in the email array might look something like this. So this is familiar to you guys, but what are some of the problems with what we have been doing so far? Well, the first is data has to be manually defined and created. So I'm pretty sure you guys have already noticed this by now, but in your P4 and P5 where you made the playlist and where you made your restaurant app, it was really annoying for you to have to create every single restaurant by hand, right? You need to define all the names, you need to define, the types of foods that are served in the restaurants, and the album or the song artist album. And it's just really annoying to have to like manually write that in every single time, right? Another problem is any updates to our objects or to our data has to require manual change in the code and then also a rerun of the app. And so, obviously this is also annoying, right? If you want to add an element to your array, you have to like just manually put that in and then rerun your app. And then the third disadvantage is that data is stored locally on your app, and therefore users cannot share data with each other. So again, because you're defining everything in your file locally, there's no concept of like being able to share this with other people or have multiple users interact and affect changes in the data. So, the solution to all of these problems is networking because networking allows us to, so basically, by communicating with other computers, we can do things like we can store all of our data together on like another machine, and then we can simply make network calls to get back that information from the machine and display that in our app. And the other advantage is that because now we're talking to the greater internet, we can talk to any machine and basically get any information that we might need and that we might want to display within our app. So now that we know why we might want to connect our app to internets, how do we actually do that? So the answer to that question is we do so by making HTTP requests. So, what does, HTTP request mean? Well, HTTP request is just a name for when one computer requests to get information from another computer. And so in this case, the terminology that we will use are clients and servers. So basically, HTTP requests are a form of communication between clients and the servers. And in the context of iOS development, our app is the client and the server is any computer on the internet. Yeah, and as you can see from the diagram, you basically have one server that's kind of like one machine, like one computer or like a set of computers, and different clients can make calls and requests to the server. So those clients can be, your website or your app, or it could be like another application, like another window application maybe. Um, Yeah, so this slide just kind of formally defines some of these terms that we're using. So the internet is a global network of computers that communicate with each other. So yeah, and then clients are, devices or software or program that calls on a service, and servers are devices or software or programs that are called on by another service. Clients and servers are basically all just like computer programs. We just use the term clients to refer to programs that call on, that request stuff from servers, and servers are programs that fulfill those requests by clients. So the types of HTTP requests that we will mainly focus on are get, post, and maybe delete. But there are actually a ton of different requests that you can make, and you can just look that up on Google to learn more about them and how you can use them. So get requests are used to basically retrieve or get data from a server. And then post is used for us to send data to the server. And usually this is to create a new model or maybe to update an existing model. And then delete is used to tell the server to delete some model. So we can kind of think of this as, before in our application, we were manually creating all of these songs, and then we have like a model for the song, we have an array for the song. Now we can just think that like, oh, maybe that array is stored in some computer somewhere else, and they have models. If we ever need to make changes, we just do so by telling the server to change it. And if we want to get all of the array of songs, we just tell the server to give it to us. And then if we want to like delete a song, we just tell the server to delete it for us. So how do we actually communicate with servers, right? So we know that we want to get something from the server, we want to send something to the server. How do we actually do that? So to understand how we do that, we have to first understand what JSON is. So JSON it stands for JavaScript Object Notation, and it is just a format for storing and transporting data. When you break down JSONs, they're basically key value pairs that are very similar to dictionaries. So the keys will always be strings, and the values can be a variety of things. So, they could be strings or numbers, they can even be objects or arrays. And if they have no value, they can even be null. And the idea is that servers will send data to us in this JSON format, and our apps will also send data in this JSON format to servers. So if we take a look at this example, we can see more so what I mean by key value pairs in a dictionary. So these like squiggly brackets basically signify an object or like like one piece of JSON information. And as you can see, we have keys such as name, number, and instructors. And then we have values that are a lot of different types. So values can be strings or numbers, and also instructors, the value is an array, but the array holds objects. Yeah, and so this JSON is basically kind of like a string. And so JSON is just a standardized way in which servers and clients know how to speak to each other because then they can parse the information in the same way. So how do we actually make these requests within our iOS apps? So, to get to the bare bones of it, in order for us to talk to a different server, we just have to send and retrieve data in this JSON format. Basically, we want to send what we want to we want to serialize what we want to send into this JSON format, and then when we get back information from a server, we want to deserialize it into the models that we know how to work with. So there are native ways within Swift to actually do this, but the way that we're going to be doing this within our course and the way that most iOS developers do this is actually through an external networking library called AlamoFire. And so the basic idea is that AlamoFire makes it a lot easier for us to make these network requests because it handles all of the dirty work of handling like annoying Swift code. So, you know, what I said earlier about like we have to serialize our information into JSON and deserialize it back into our model object, you know, actually making the call to the servers. All of this is actually very complex to do if you want to like write the code yourself in Swift. There are a lot of like nitty gritty details. There are just annoying code setup, very verbose code setup. And generally, if you can avoid doing that, we want to. So yeah, so Longfire is an external networking library that's built specifically for iOS and macOS, and we can just use that to handle a lot of these like networking routes for us. So I said earlier that AlamoFire is a networking library, right? So what are actually like what do I mean by external libraries? So you know, basically external libraries are kind of like like sets of code that somebody else has written that we can use to carry out some sort of functionality that we don't want to write ourselves. And so usually, you know, when we're trying to accomplish a task, um, it can be a really annoying and maybe a waste of effort for us to write every single thing by ourselves, especially if somebody else has already done the same thing. And so external libraries basically allows us to save time by just reusing code that some other developer has written. So yeah, when we want to do a certain thing within our application, we can just use the library code. We can just call the library code, but then under the hood, that library code will execute the appropriate code in our language to do what we want. And so some examples that maybe we can look at is, you know, if we look at our app Eatery, if you open our app, we can see that like we have some really nifty transitions, such as like you open the app and things fade in. And I believe when you click on any single one of these like eateries, it will also fade in. So that fading effect, there is certainly a way for us to write it manually in Swift. You can use a lot of, like there are animation like frameworks and UI kit that you can kind of use. But it's really annoying to do that, right? And so, you know, if we can avoid doing it, we will. And so there is this library called Hero Animation that we can use to do all of these things. So that library will execute all of the dirty work, or that library will do all of these like annoying uh, they will implement all these annoying code that we don't want to write basically. So all we need to do is call a function provided to us by Hero Animation. And similarly, if we look at Google Maps or our eatery or our transit app, we use the Google Maps library. So that's how we actually get this like really nice map in our app. Of course, there is probably a way for us to make a map ourselves, but why do we want to do that if we don't have to, right? So because Google Maps already provides this functionality, all we need to do is call their code, and then it'll show this map on our screen. And lastly, another library that is really nifty is this library called Lottie, which is actually made by Airbnb. So basically, by using their library, they can provide a lot of cool animations for us that we can just use. So again, I'm sure we can write these animations, but as you can tell, this kind of animation will take a lot of time, right? Using Lottie makes our lives much simpler because we can just use this animation, or we can use like any animation from their vast library of animation, and we can just add that into our app. So, how do we actually use these libraries? Well, there is this thing called CocoaPods, which is basically an external library manager, and it is specifically for Swift and Objective-C. So if you have any experience with Python, or if you have any experience with Node.js, you'll know about tools like pip and npm. CocoaPods is very similar to pip and npm. So, essentially CocoaPods, they host a lot of different libraries. So by their numbers, they host over 45,000 libraries, and those libraries can be used, they can readily be used in your apps. And so the idea is that by using CocoaPods, you can very easily just download libraries from CocoaPods, and then you can just start using them within your app. And then you can also very easily manage those CocoaPods by detailing all of the ones that you're going to be using within one single file. So in order to actually start using CocoaPods, you have to first install CocoaPods onto your machine. And so you do that by doing sudo gem install CocoaPods in your terminal. And we'll go through this demo later so you see what I mean. And then once you've installed the CocoaPods, you just have to go into the folder with your project, and you want to write pod.init, and this will create a pod file for you. So the pod file will basically look like a text file basically. And so as you can see in this on the left hand side, we have a screenshot of an example of a pod file. So basically it lists all of the libraries that you want to use. So here we see like AlamoFire is a library that we're going to use to execute our network calls, right? And then there are things like Google/signin, which is also a library that you can use to sign onto Google. And there are so many libraries you can use, but the idea is that you'll just list all of them here in the pod file, and then you can just install it, and you can delete pods, add pods as you need. So when you click, so once you edit this pod file, if you run pod install within your terminal, this will actually install all of these libraries onto your project basically. And it also creates another file called the XC workspace file. It is very important to remember that when you use CocoaPods, you have to always open this workspace file instead of your xproj file, because this workspace file will include all of the pods that you're going to be using. Yeah, so lastly, I just want to spend some time talking about closures. So I also want to make a note that this week's project will be a lot more light than it usually is. So this week we're going to be doing an extra credit project on closures. So it is not required, but closures are used a lot in networking and also in handling responses that we get from networking. So we just wanted to kind of go over closures today and also give you a chance to work a little bit more closely with it through our extra credit project. You can choose to do it, or you can choose not to. I would recommend that you do. But if you are like already behind in other projects or in other classes, I know, this time of the semester is especially difficult, then you don't have to worry about the project. So yeah, closures. What are closures? Well, closures is basically a fancy name that we give to basically functions, right? So closures are self-contained blocks of like functionality that you can pass around in your code that you can use in your code. But basically, they're just functions. They're just functions that are defined a little bit differently. So if we look here at closures versus functions, the first example here, this is a closure, right? So we say let add two numbers is equal to this bracket first, second in return first plus second, right? So this is kind of like a funky kind of syntax for declaring a function, but this really acts the same as the second example of func add two numbers first, second, and then return first plus second, right? These two basically do the same thing. It's just that in the second example, you're formally defining this function. You're declaring it as a function, and then you're kind of declaring the parameters you're going to put into the function, and then you're explicitly returning. Closure is just it does the same thing, but you don't have to formally declare the function. And then there's also some like small differences in how you actually then use these closures and functions. So yeah, so so to use the closure, you just have to pass in these numbers that you're going to be using, whereas in the function, you have to like state that the parameters correspond to these arguments. So, what do we actually do with closures, right? So, because closures are self-contained blocks of functionality, you can do things like you can pass them as arguments into various like higher order functions, right? So in Swift, or I guess in programming, there are things called higher order functions. And in Swift, some examples are map, filter, and sort. And basically, higher order functions are functions that take in other functions as input, right? And so because, these functions take in functions as arguments, basically, defining them as closures allow us to do that. So if we have a function, we won't be able to just like pass it in. But in this case, we can just say like, um, you can see like on the second line, the bracket num returns bool, and then it says in return num uh, greater than or equal to 0. So this is the closure part, and that is basically the argument that we're passing into this map function. And so some example, or so to kind of explain more about like what map does and what filter does, map basically takes in it basically operates on a list. So it takes this function and applies this function to every single element in your list and returns a new list. So in this case, we're going through our first list, and we are saying that we're going to return the Boolean that tells us whether or not that number is greater than or equal to 0. So it returns another list, which is why map list is now a list of Boolean values. And then filter is another example of a higher order function. And this function basically goes through your list, and it kind of filters out any value based on a certain evaluation function. So in this case, we're going through the values array, and any value that is a multiple of 2, we will remove. And it returns a new array, and so that's why even is an array of all odd elements. So these are just some examples of higher order functions. They're really handy to work with, and you can look up more on Google and then choose to use them in your app as needed. So this is one example of how closures are used, but as we kind of get more into our networking, you can see that we can actually use closures to also handle responses from our networking calls. So you'll be seeing more of that next week. Okay, so for today's demo, we're going to be building out this app that you see here on the right. Essentially, what we want to do is we want to be able to get a JSON object from the internet. In this case, it is going to give us an array of classes, and we want to display those classes inside of a table view of our app. So today's demo will focus on one, installing CocoaPods so that we can actually use AlamoFire, which is the library that we're going to be using to make network requests. And we're also going to be going over how to actually make a network request so we can actually get this JSON object back when we kind of like hit an endpoint on the internet. But we're not going to be actually building out the table view of the app itself. So in next week's lecture, Matthew will show you how to do that, and he'll also show you how to actually work with this JSON that we get back from the internet. So for the demo, we have already provided you guys with a starter file. So you can just go into our iOS course textbook website to download that. But here I just have the starter file on my desktop. And if I click into it, you can see that we just have a folder here with all of our files. And then we also have our L6 starter Xcode proj file. So let's just kind of open that up and take a look at what is provided in the starter file. So when we look at the file hierarchy here, you should see some files that are very familiar to you guys. So we have our usual app delegate, and we also have our usual scene delegate. And we also have a view controller here. So let's just take a look at what our view controller has so far. Basically, we have a table view here, and this is going to be the table view that we will use to display all of our classes. And we also have a data variable courses array here. So this is going to be the array that will hold all of the courses that we show in our table view. And here we just have the regular view did load function that you guys should be very familiar with by now. And we have our setup constraints. A new function that we added is this function called get courses, and this is where we're going to be putting all of our code to actually get the courses from the internet. And here we just have some extensions. So, to implement the functions for our table view data source and also for our table view delegate. So what you'll see is that, we actually don't have any code inside of this extension. And the reason why is just because we're not actually going to be working with the table view today. And since none of the functions inside of UI table view delegate are mandatory, this doesn't throw an error by not having any code in here. And so if we take a look at our other files here, we see that we have a course struct. So here we just help you define what a course object should look like. And here we also have the courses table view cell. We're not going to be very concerned with this at all since we're not actually going to be using this file today. But the file that should look kind of new to you is this networkmanager.swift file. So this file is basically going to be where we put all of our network call code into. So this file will contain all of the code where you make like your get requests, your post requests, etc. So generally it's just good practice to organize all of your network related functions into one file. So it's easy to kind of like find things and easy to debug later as well. So yeah, so this is just all of the files that we have, but as I mentioned in the lecture, we're going to be using an external library called AlamoFire to actually help us make network requests. And again, the reason why is just because AlamoFire makes life a lot easier for us. It simplifies the process of making get requests and post requests, and also decoding and encoding information that we get from those endpoints on the internet. So we're going to be using AlamoFire. So to actually use AlamoFire, we have to install CocoaPods first of all, and also initialize our pod file inside of our project. So to do that, let's just click out of our project altogether, and let's open up our terminal. And then here you just want to say sudo gem install CocoaPods. And you want to put in your password. And as you can see, it'll start to install CocoaPods, and Yours might take a little bit longer since I already have CocoaPods installed. It takes a lot less time for me. But once you have done this step, you should be able to use CocoaPods inside of your project. So what you want to do now is you want to navigate into the directory that your L6 starter file is in. In my case, it is in my desktop. So I'll just say cd desktop, and the name of my folder is L6 starter. So I will just click enter and navigate into it. And now that we're in the directory, we can confirm that it is the right directory by doing ls, and we should see all of the files that we expect. So again, if I open this file, or if I open this folder, you'll see that I have indeed these files. So what you want to do now is you want to initialize CocoaPods for this project. So to do that, you want to say pod init. And when you say pod init, what it will do is it will create a pod file for you. And it'll create a pod file for you. So what you want to do is this is where you're going to be actually putting in all of the pods that you're going to be using or that you want to install and use in your app. So in our case, we want to use AlamoFire, right? So what we can do is just go to this line, pods for L6 starter. We want to do enter. And now we just want to say pod AlamoFire. So this just indicates that AlamoFire is a pod that we want to use. So now you just want to save that. And once you have done that, what you want to do is you want to say pod install. So this will then install AlamoFire into your project. So here you can see that it is installing AlamoFire. And what this command will do too is this command will then create another kind of file for you called the XC workspace file. So after you've installed your pods, you're going to want to start working on this file and not your old Xcode proj file. And the reason why is just because now like this is a file that can actually that actually contains the pods that you want to be using. So once we've done that, we can just click into our L6 starter workspace and open that up. And it should look very similar to what you had before. The only difference is that now you have your L6 code here, L6 starter code here, but then you also have this other kind of like pods file. And this is where all of the pods that you've installed will kind of go. Yeah, so if you click on here, you'll see these files are basically what we had before. So once we have installed AlamoFire, we can actually get started on making this network request. So what we want to do first is let's just go into our network manager, right? So I just want to show you how to use AlamoFire to make a simple GET request. So the first thing that we want to do is we want to create our network manager class. So we'll say class network manager. And here we're just going to define an endpoint. So I'll just say static let endpoint is equal to this URL. So the URL in our case is this URL. This is actually the URL that we're going to be getting our JSON object from. So let's just kind of take a look at what is at this endpoint, right? So if I open up a new window and I go to that endpoint, and I click enter. Oh. So let me just, so if I go to that endpoint, we'll see that at this endpoint is basically the JSON object that we want, right? So this website is actually the website that our previous course instructor set up for us. So she's currently hosting the code, or she's hosting this object on her website. So the idea is that we want to hit this endpoint and we want to get this JSON object and get the information inside of it into our app. Um, yeah, so let's just inside of our static or inside our network manager, let's define a function to actually get this JSON object. So for that, we'll say static func get courses. So this is where we're going to be putting our code to get courses. So let's just make a note that we kind of declare our function and our variables slightly differently here. Namely, we have this static keyword, and I'll maybe talk more about the reason why we have this later. But basically, we added the static keyword because we want to be able to call this function without having to initialize our network manager. So that's kind of like the simple explanation, but I'll kind of show you what I mean later when we actually call this function. So inside of get courses, we want to actually use AlamoFire to make our get request, right? So to do that, we have to first import the pod into this file. So to do that, we'll say import AlamoFire. So by doing this, we can then start using like whatever code that this library provides. Yeah, so right now it's giving an error that says no such module AlamoFire. You might get this error. If you get this error, one thing that you can do is you can go into your product and say clean build folder. And then you can also do build. And so by doing that, basically it will kind of reset all of your files and make sure that AlamoFire is kind of like included into your project build. So yeah, you can see here is building your project and adding AlamoFire. So then that error should go away. Okay, so once you have AlamoFire installed and imported into your project, we can start to actually use AlamoFire in order to help us make our GET requests. So the syntax for that is we're going to do AF dot, and then we're going to use a function called request that is provided to us by the AlamoFire library. So if you put in request, some of the function options should come up for you. So I think the one we want is this first one that says method, parameter, encoders, headers, and etc. So let's just click on that and it will kind of give you the template to fill in. One thing to note is that depending on what version of AlamoFire you have, you might have to say AlamoFire.request. So that's if you have the older version of AlamoFire. If you have the newer one, you should just be able to do AF.request. Yeah, so now let's just try to fill in these parameters. So this first parameter is the URL that you want to hit in order to get your JSON object. So in our case, that URL is the endpoint. And then for methods, this is what we talked about with like the get request and like the post request, etc. So in our case, we want to do a get because we want to get the object from the endpoint. So for that, we'll just say HTTP method dot, and it's an enum. So as you can see here, we have a lot of options. So we have like delete, get, post, which we talked about. We just want get, so we'll say get. And actually, we don't need any of these other parameters because we're not really using them for now. So we can just erase all of those. So this code will basically make a GET request to the endpoint that we have specified. So from there, what we want to do is here. Okay, so we don't. So here, let's see. What we want to do is once we get back the response from the endpoint, we want to validate the response. So we do that by saying validate. And then because the response is going to be JSON, we do response JSON. And if we just do enter, it'll show you that like this now requires a completion handler, right? So what happens is this part of the code will go into your endpoint and it will get back your JSON object and it will validate it, it will recognize it as JSON. But then once the data comes back, you have to actually handle it, right? But the problem is that like network requests can take some amount of time, right? So it might take like 1 millisecond, 2 milliseconds, 3 milliseconds. The point is that you don't know, it's not instantaneous when you would get back the response. And so this will then take in a closure, which you might know a little bit more about if you do the extra credit assignment. But we did talk about how closures were basically like functions. So basically, the idea is that whenever the response is retrieved, we want to apply the function to the response. So in order to do that, we can just replace this and make a curly bracket. And this is where we're going to put our closure. So the closure will take in an argument called response. And then we'll use that response inside of our closure. So to basically give you an idea of what the response will look like, it will basically look something like this. So the response will come back with kind of like, it's like an enum. So either it will be a successful response or it'll be a failure response. So there will be success, the success case, in which case it will just contain a data of type T, which is any, and that just means that it can be anything inside of this response. And then it could also be a failure. So in that case, it will be a failure and it will also contain an error. So whenever you make your network request, this is the kind of response that you're going to get back. So we want to handle both cases of if it's a success or if it's a failure. So to do that, we can do switch response.result. And in the case of a success, we want to unwrap this data inside of our success. You want to do something. And otherwise, if it's a failure, then we can just unwrap the error and then handle that. So in our case, we'll just print the error. And if it's a success, then we can print out the data. So yeah, so this function will basically go into your endpoint. It'll get the JSON object, and then it'll handle it based on whether or not the response was successful or if it was a failure. So now let's actually call this function, right? So we're going to put that inside of view controller inside of this function get courses. And the way that we're going to do that is we're just going to say network manager.get courses. So earlier I explained that, a difference in how we declare the function and variable in Network Manager is that we have the static keyword, right? So the reason why we do that is because by adding the static keyword, now we can call get courses directly on Network Manager. Without the static keyword, so for example, if we get rid of this and it's just func, then this will now throw an error. So we try to run it, it'll tell us that there is an error because get courses cannot be called on just the class itself. It has to be called on an instance of the class, meaning you're going to have to like make an instance like network manager is equal to network manager like this, and then you have to call it on this instance. But generally, we want the network manager to contain your request calls for the entire app. So it makes no sense to be initializing a network manager instance in each file. So that's why we have the static declaration. So we'll just do network manager. So all files will basically call this function on the same class. Yeah, so let's just fix that in network manager. So now let's try to run our code. Yeah, so now what's going to happen when we run our code is it's going to execute the view did load, and then it will call our setup constraint and also call get courses. So So let's just wait for our app to load. Okay, yeah, so now the simulator has run. And as you can see here, we do in fact print out what we get from our endpoint. So yeah, so in the next lecture, you're going to learn how to actually use these objects inside of your app. So you're going to learn how to show this in your table view. And yeah, so for action items for next week, as I mentioned, we won't have a regular project this week. So there's an extra credit closures playground assignment out. So if you have time and you want to learn more about closures, you can do that for some extra credit. And that will be due next Sunday at 11:59. And we will not be taking late submissions for this.